Use the extreme value theorem again to find the maximum values, absolute max or min for this function. We already know this is a trigonometric function. Sine of x is defined everywhere, and so is cosine. So this function, which is made of both of them, should also have the same domain, which will be from negative infinity to infinity. So it is going to be continuous, and we're only looking from 0 to 2/3 pi or 270 degrees. And again, first thing I do is we want to make sure that we find the derivative. And the derivative of this function is going to be 2 sine x times cosine x, the chain rule, minus, and then since it's already a negative, we're going to use plus sine of x. We make this equal to 0, and we try to simplify this a little bit further. We could take out a sine x from both terms. And now you just ask yourself, when is sine of x equal to 0, and when is 2 sine x plus 1 equal to 0? So just real quick, sine of x is going to be equal to 0 at 0, and is going to be equal to 0 at pi, because we know that sine is the y value or the opposite side, so this would be the y value. And again, this happens when x is equal to 0 and pi. And then the last part is we want to know when sine of x is equal to, in this case, if we solve for it, it would be negative 1/2, right? So we want negative values of 1/2. So I can have my function here, and we know that sine is going to be 1/2. But this 1/2 right here would be a positive value. So we want to make sure that it's a negative value, and we know sine occurs on the third quadrant, it would be negative 1/2. And on the fourth quadrant, we would also have that negative 1/2. So opposite of 1/2 is going to be 30 degrees. So this is going to give us 1/3, 2/3, 3/3, 4/3 pi. So this would be 4/3 pi. And again, the negative value over here would be 1, 2, 3, 3/3, 4/3, 5/3, 5/3 pi. And again, you just enter these values on your calculator, and you just find out which ones are going to be, again, the lower amounts. I should have labeled that h of x. So anyways, we have a 0, we have pi, we have 4/3 pi, and then finally the 3 pi over 2. And you just plug in the numbers and you figure out which ones are going to be the lowest. And I'll let you guys plug those numbers in so you guys can figure out when it happens. But the minimum in this case would be at -1. So you tell me which one of those values it equals to, and the maximum is going to be at 1.25, or not at, but it's 1.25. Okay. For this function, they want us to find the max and the min from -2 to 5. Just know this is a ln function, and we have x squared minus 9 in this case. So the thing that you have to realize is that f of x in this case is not continuous, right? It's not continuous on -2 to 5, because we could have values in between here that become negative, between -3 and 3. So therefore, the function is not continuous. And as a result, the extreme value theorem does not apply. Okay, and again, If you want, you could look at this function, just look at it graphically where it's defined and see if it actually is continuous on that, and you will see that it's not. So Desmos is a good idea to go ahead and graph that in case you don't know it. All right, let's look at the last one here. This last function we know is a cube root. So first thing we do, again, we take the derivative. Okay, and when we take the derivative of this function, it's going to be 2/3. And then the cube root of x minus 2. And again, we got to make that equal to 0, right? So that means that this cannot be equal to 0. Okay, and we also know that h prime of x does not exist when x is equal to 2. And again, that's because you cannot have a 2 here, which will make the denominator equal to 0. So on the interval from 1 to 10, the only places where h of x, again, is going to be at these values. We only have x is equal to 0 at 1, at 2, and 10. And again, we know that the derivative doesn't exist, but what are the values? When we plug them in, we get 1, 0, and 4. So again, the minimum value for this function is going to be at 1, 1, and the maximum occurs at the endpoint with a value of 4, right? And again, so you just look at this, and again, we're looking at when is the equation not equal to 0, or when it's equal to 0, and we don't see that any values, but we also want to look at critical values where it's not defined or doesn't exist, and in this case, it would be 2, because plugging in 2 would make the derivative undefined. So that's how you would do this one.